Welcome to the GOB laboratory at Mercy College. In this experiment, we'll take a look at how gases respond to changes in volume and temperature. In part A of this experiment, we'll investigate Boyle's law and see how the pressure of a gas responds as we expand the volume. Here are some materials that we'll need in part A of this experiment. On your LabQuest, the first thing you're going to do is click on the LabQuest app on your home screen. This will bring you to the data collection part of the LabQuest. Now we're going to insert our pressure sensor into one of the channels available on the side of the LabQuest. We also need to change the units of pressure from kilopascals to millimeters of mercury. Now adjust your syringe so that the leading edge of the plunger lines up exactly with the 4 milliliter marking on your syringe. Attach your syringe directly to the gas pressure sensor. Carefully twist the syringe clockwise, being careful not to over-tighten or to damage the connector on the pressure sensor. Wait for the pressure reading to stabilize and record the value on your data sheet. While holding the back of the syringe, carefully slide the plunger out to a volume of 8 milliliters, making sure that the leading edge of the plunger lines up with the 8 milliliter marking on the side of the syringe. While holding the syringe as steady as possible, wait for the pressure to stabilize and then record the value on your data sheet. For your third data point, pull your plunger out to a volume of 12 milliliters and hold while you wait for the pressure to stabilize. Once the pressure reading looks stable, record the value on your data sheet. For your fourth data point, we'll expand to a volume of 16 milliliters. The syringe may become difficult to hold due to the pressure difference inside versus outside. It may take several tries to get a good reading, but once you have a stable value, record it on your data sheet. Repeat the process one last time using a volume of 20 milliliters. Again, make sure that the leading edge of the plunger is lined up with the 20 milliliter mark. Once you've obtained your final pressure reading, record the value on your data sheet. You've now finished collecting your pressure versus volume data. To get the best possible results in this experiment, it's important not to hold the body of the syringe with your hand, because your body heat will warm up the air, causing an increase in pressure. If you feel that this impacted your experiment, you may wish to repeat the data collection. To analyze your Boyle's law data, navigate to the Desmos link provided in the description below. You should see an interactive graph titled Boyle's Law Data Table. In the data table, you can enter your volume and pressure data line by line, and the graph will update as you enter your data points. Below, we have an equation that's our modified form for Boyle's law. We have a few extra parameters here to account for a few calibration issues. We see that we need to take into account the volume of the tip in our syringe, and we also need to account for the miscalibration of our pressure sensor. First, we're going to use the slider to adjust the volume of our PATM parameter, which is the pressure of the atmosphere. This should correspond to the pressure that we read when we first connect the syringe at the 4 milliliter volume. Feel free to play with the slider to get a sense of how this parameter affects our Boyle's law model. Now let's adjust our pressure calibration parameter in order to achieve the best fit to our data points. This parameter accounts for any difference between our pressure readings and the true pressure. The V-tip parameter corresponds to any additional volume that's located in the tip of the syringe that's not taken into account by the markings on the side of the syringe. Once you've adjusted your parameters to achieve the best fit of your model to your data, make sure that you record the values of those parameters on your data sheet.